Hello everyone, welcome back to the computer network course. So guys, in our previous videos, we have discussed complete about IP. What is IP? Internet protocol, right? Datagram, fragmentation, options, all the fields that are there in the header, we have discussed it, right? So now in this last lecture, last series of the internet protocol thing, we will discuss about the IP package, the complete IP package. Okay. So this diagrams you can see is an example, it is an hypothetical IP package. Okay. So IP package has 8 components. Okay, these are all the 8 components which are there in the diagram. Let's discuss it in detail what these components do. Okay. So first, what's happening? Okay, so first from the upper layer, this is one first component, header adding module. The name suggests header adding module. It add the header thing, right? So first what's happening, from the upper layer, data is being received along with the destination address. So from the upper layer, data plus destination address is being received to the header adding module. Okay, the first module, header adding. What header adding module do? It encapsulate the data. Encapsulation means to add the header, IP header to it. It adds the IP header. Okay, it adds IP header means it encapsulates the data in the form of datagram. Okay, it encapsulates the data in the form of a datagram, the packet, the datagram, we can say in the network layer. So it encapsulates that packet, a datagram, and sends it to the processing module. Okay, then this datagram is sent to processing module, the second module. Okay, so the processing module, it can receive data from two okay parts. First from the header adding module, and second it can receive data from data link layer also, from different interface also. So but it treats all the datagram which he received, the processing module received, as same. Even if the datagram is received from header adding module or from the data link layer, it treats both the datagram as same. Okay, so what processing module do? It first check, okay, it check if your datagram is reached the final destination or not. Okay, so first processing module do is it check if your datagram has reached to the final destination or not. If it has reached to the final destination, it sends that datagram to reassembling module, the third component, reassembly module. Okay, if it is not the last destination, if it's not his destination, he has to move to other routers as well. So what it does is processing module, it decrements the time to live, right? It decrements its time to live. And if the time to live becomes 0, it discards a datagram. Otherwise, it sends it to that IP packet datagram to the forwarding module. Okay, another component to forwarding module. So what's happening first, the data and destination is coming from the upper layer to the header adding module. Header adding module encapsulates the data in the form of header, adds the header to it. Okay, then that header, that datagram is sent to the processing module. Processing module receives datagram from 2 layers. First from the data link layer and other from the header adding modules also. So it receives data from 2 layers. Okay, it check if the datagram has reached the final destination or not. If it has reached, it sends it to the reassembling module to reassemble. And if it's not reached, it first decrement the time to live and sends the datagram to forwarding module. Okay, then again, it has a queue. Okay, the queue is not mentioned, it's not a part of the component. It has a queue. The IP package has a queue. It has 2 queues, input queue and output queue. Input queue is used to store datagrams that are coming from data link layer. Input queue stores a datagram that are coming from data link layer. Output queue, it stores the datagram that are going to the data link layer. Okay, this is the function of queue. Okay, now what happens? First, the IP packet goes to the datagram goes to forwarding module. Here we have a routing table. It checks the next hop. We have already discussed the function of routing table, right? It has the address of the next hop, where the datagram has to move to the next hop. Okay, So forwarding modules, with the help of routing table, it checks which is the next hop address. Then it sends the packet along with the next hop address to the fragmentation module. Okay, so it adds the next hop address to this datagram. See here, the packet has next hop interface along with the next hop interface along with all the packet, the information that it has, it sends that to the fragmentation module. Okay. Now what fragmentation module do? Fragmentation module first receives the datagram from forwarding module. It has the IP address of next hop, right? Okay. Then it has the MTU table. What MTU table is? MTU is maximum transmission unit that I have discussed in the fragmentation video, right? Maximum transmission unit has two columns. First one is interface. Second one is MTU. So for each and every interface, it has the maximum transmission unit. So with the help of MTU table, fragmentation module checks. It has the next hop address and interface along with the MTU. So it checks if the MTU size is bigger. If it is bigger, then it fragments, it divides the datagram. Okay. If it is not, it sends that to the, then it divides the packet. Otherwise, it sends the whole datagram to the ARP. ARP is address resolution protocol, which we'll discuss in our next video only. Okay. So IP packet next hop to data link layer or ARP. Okay. So what we have discussed till now, processing module takes that packet to the forwarding module. Forwarding module along checks in the routing table the next hop address and it sends that to the fragmentation module along with the next hop address. Now what fragmentation module do? It checks the MTU, right? MTU has interface along with its maximum transmission unit and it checks the next hop address and its MTU. If it is greater, then it fragments that datagram, or it is not, it sends the whole datagram to ARP, address resolution protocol. Okay, this thing is clear. Now let's go to the reassembly module. So here is a reassembly table. So here you can see reassembly table has these 5 columns, 1, 2, 3, 4, 5. Okay, this is first state, source address, datagram ID, what is the timeout, if it is timed out or not before reaching this, or the fragmenting. Okay, so it has all this information, the reassembly table. Reassembly module, what reassembly module do? As the name suggests, when we receive different fragments, right? Datagram is divided into different fragments, right? So it have to reassemble all the fragments which are of a particular datagram, right? Fragments can be of different datagrams also. So it has to reassemble the particular datagram fragments along with its correct order also. So with the help of this reassembly table, which has all the information about fragments, about the state and all the datagram ID. So along with all the information, it reassembly module reassemble the fragments and sends it to the upper layer. The data is sent to the upper layer. Okay, so this is the complete IP package. I hope you understood. Let me just quickly revise it. First, data and destination data comes from the upper link layer. The header heading module adds the header encapsulated in the form of datagram, sends it to the processing module. Okay, processing module can receive datagram from data link layer also. What processing module it processes? It checks whether the datagram has reached the final destination. If it has reached, it sends to the reassembly module to reassemble all the fragments with the help of reassembly table and sends it to the upper layer. Okay, if it is not, it first decrement the time to live and forward it to the forwarding module. Forwarding module checks in the routing table. Routing table has next hop address where I have to forward, right? Forwarding module check where I have to forward. The next station is where, right? It checks the next station, next hop, and sends this to the fragmentation module. Fragmentation module has next hop address also, and with the help of MTU, it checks whether MTU is bigger or not. If it is bigger, it fragments this. Otherwise, it sends the whole datagram to ARP, address resolution protocol, which we will discuss in our next video. Okay, so this is the complete IP package. So we are done with this Internet Protocol version 4. Okay, the complete series we have completed. Okay, so now in next video, we will be starting with ARP, address resolution protocols and all the things. Okay, so thank you.